What's up, students? We got an AP problem coming at you. All right, let's get started. A pebble of mass m is loaded into a slingshot and pulled back at constant velocity to a distance of 3d. The elastic acts like a massless spring. So what does that mean? We can use some spring equations on this thing. Okay, so let's kind of go over what it looks like. So we start out with our slingshot, and the spring or elastic is not really stretched yet. Now, when we start stretching it, we do it at constant velocity, and as we're stretching it goes to d, then it goes to 2d, and then it makes it to its maximum distance of 3d. Now you can see at the right we have our force applied versus distance graph, and you can see that it goes up kind of linearly. Okay, so at our 3d distance, when it's pulled back at maximum distance, it looks like our force required to hold it there is F3. Now you'll notice with these AP questions, the free response questions, a lot of times they don't give you constants or numbers for anything. Usually it's only in variables, and that can make it kind of tricky. So it's good to get in good practice of doing that. Okay, so let's look at part A. Rank the net force on the pebble at locations D, 2D, and 3D as it is being pulled back. Alright, we're going to look at part B. Find the K value of the elastic band in terms of F3, the force at 3D right here, and D. So our answer for this one should only include variables F3 and D, and some other numbers and stuff. Okay, for part C, it's asking determine the work done by the person, by the elastic, and the total work. Part D asks how many times greater is the elastic potential energy at 3D compared to 2D. So at this point right here compared to this point right here. Okay. And then for part E, it asks if the pebble is released horizontally from a height of 16d, find the distance it travels in terms of F3, D, and Fg, which is the force of gravity on the pebble. So this problem might look a little bit like this. We have our slingshot, and this is going to be a height of 16d, and here's the ground, and it launches and it lands at some distance that we're trying to find, and we'll call it delta x. Okay, so here's the problem in totality. You can pause it if you want and try and solve it on your own. Actually, please solve it on your own. Give it a shot. Try and go through all A, B, C, D, and E if you can. And in the next video, I will go through it and solve it with you. All right, see you in the next video.